Well, hello friends, and welcome to the SerenityOS update for January 2020. Before we begin, let me tell you about sponsorship real quick. So the Serenity operating system and all of my content about it is always going to be free and open source. But if you would like to support my work and maybe one day make it possible for me to do this full-time, then there are 3 donation options at the moment. So I'm on Patreon, I'm on GitHub sponsors, and those are for people interested in making a monthly contribution. And then I'm also on PayPal if you're more interested in making a one-time contribution. You can find links to all of these things in the description below. And of course, a huge thank you to those of you who are already supporting me in some way. Thank you so much. It's really awesome. Okay, so what's been up in the new year of 2020 so far? After Christmas, there was a sudden shift in an interest in security for me because Serenity was hacked in that capture the flag thing at the 36C3 event, and I just ended up on a path of learning about security. So it's been a lot about that for me. And I've been trying to get into the mind of a computer hacker and just trying to learn how to break into systems, specifically Serenity, so that I could improve it as I go. And of course, a lot of interesting security mechanisms and mitigations and improvements have come out of this. So they're a little bit less visual, but let's still talk about them, right? So first thing is, basically, most of the X86 hardware mitigations are now turned on. So we have SMEP, SMAP, UMIP, we have eager floating point restore, we disallow I/O from user space, we don't let you access the timestamp counter from user space anymore, and then we've hardened the kernel image so that there's no writable code in the kernel and there's no executable data in the kernel. We also expanded the use of the NX bit. And that's hardware, and then also in software protections in the kernel, there's a lot more syscall validation going on now, validating inputs and memory ranges and stuff like that. And we now enforce file descriptor modes so that if you open a file for reading, you can't write to it, which was previously possible. And then we have made a bunch of things super user only. So like you can no longer load modules if you're not super user. You can't do various things like make device files and stuff like that. And actually I can show you an interesting new feature is that we have bind mounts and mount flags, which is something that Sergey worked on. So if we, oops, forgot the first letter. If we look here, we can see that slash is mounted no dev, no SUID. That means that in the entire slash file system, so the whole file system, we don't allow device files and we don't care about set UID bits. And then we use bind mounts to specially mount slash dev and slash bin. So device files are allowed in slash dev and SUID files are allowed in slash bin. This means that you can't create a device file anywhere else but slash dev because the system is not going to care about it. And likewise, you can create an SUID file, but the kernel is not going to change the user ID of the program unless it is in slash bin. So, it's a very, very nice safety mechanism, I think. So thank you, Sergey, for working on that. And then, of course, I implemented the first iterations of Pledge and Unveil this month. So those are 2 mechanisms from the OpenBSD system. And I've talked at length about them in other videos, and I definitely encourage you to check that out if you're not familiar with Pledge and Unveil. Very, very cool mechanisms. And of course, they are still very immature in Serenity, and they don't cover everything that the OpenBSD implementations cover, but it's something that we can improve as we go. And actually, I can show you how we expose pledges in System Monitor. So just in case you're not familiar, basically pledge is a way for a process to say, I'm only going to be doing this set of things. And then if that process does anything that's outside of the set of things he said he would do, then the kernel will kill that process. So it's a way to opt into a reduced feature set, basically. So we can see here that the system monitor process is running with a pledge of this set of features. So basically standard input output, read file system access, some amount of process control because we have these like kill, process, stop, and continue here. So we need those. We need proc for that, and then accept so that we can accept incoming IPC connections for debugging features. And then shared buffer is something that's needed by all GUI programs in order to exchange bitmaps with Windows Server. Now, this program does not have the ability to create a new file, for example, because for that you need cpath. So that's down here. Shell has that. Shell is allowed to create a file, but System Monitor is not. So if the System Monitor, for any reason, would get compromised or confused, some bug would happen, it would try to create a file, it would crash instead of creating a file. So I think that's a very, very cool mechanism. And then we can also see here that the veil is locked. And what that means is that this process, in addition to opting into a restricted set of system calls, it has also opted in to a restricted set of file system paths that it can access. In this case, this process only has read access, and it can only read from these 4 places. So that's pretty cool. And we can see here that a bunch of programs have locked veils. And this guy right here, terminal, he's allowed to read, write, and create the terminal.ini config file. And he's allowed to execute bin terminal, because if you create a new window in terminal like this, then actually that's a fork and exec. So we allow that. Yeah, so that's a little bit about pledge and unveil. So what else did I want to talk about? We've done a bunch of randomization stuff. So the initial memory map address in a new process, I can show you here. This is now randomized a little bit so that every new process doesn't start out at the exact same location. So you can see here, like these are sorted. So they all start out at slightly different addresses, right? Which is nice because I found, as I was learning exploit development, I found that it was very easy to exploit the program loader in the kernel because the first mmap in every new process was always in the same place, and the ELF binary was always loaded in the same exact location, which made it trivial to exploit that. So I just added this bit of randomization here just to challenge myself a bit more with the exploitation and you know, just to make it a little bit less predictable. And some other things that are randomized. We now randomize the stack a little bit when you do a system call. Then we add a random offset to the stack to make it a little less deterministic. And we now randomize TCP sequence numbers, and DNS request IDs are randomized, and we actually also randomized the case of DNS lookups, which is a very, very neat feature that I learned about. And from an old bug report, actually, that Holger filed, which I thought was really cool. And yeah, I read that some websites or some sites don't actually support case randomization in DNS lookups, but hopefully we can work around a few things that need to be on a blacklist or something. Anyway, I also did a bunch of other improvements to the DNS lookup system. So we now cache DNS answers for as long as the service says we should cache them. And we verify that the DNS response that we get actually matches the question that we asked. So just a bit of DNS hardening, basically. And we've also been hardening the system in general. So if you look in /proc, for example, we can now see that a lot of these files here are not readable unless you are root. So anything that might contain sensitive data, like the system log, for example, the message is root only, and stuff like the module list and the memory management information. And then all of the process directories are owned now by the user running the process, and they're only readable by that user. So I can go into the Windows Server directory here, for example, and I can see that it's running, but I can't actually look at the CPU registers of this process. I have to be root if I want to do that. And some neat things like this. And I guess another thing that we've also hardened is the various Rpc sockets that we use. You can see here that the lookup server, which is the DNS lookup service, it now runs as a separate lookup user. So you can see it reflected here. The alignment here is bothering me right now, but what are you going to do? So anyone in the group lookup can access this socket and make a DNS request. And then it executes as lookup. So if there were some vulnerability in the DNS lookup code, then it wouldn't affect my my normal user account as much, because it would only be able to compromise the lookup server. Maybe we can, we'll make a lookup and then we'll get a lookup server. We can see it here. Right, we can see lookup server running as user lookup. And it has a locked veil with no file system access whatsoever, and it can only do this very small set of things. So it's a very, very tightened situation for the lookup server. And we've actually also done the same for the protocol server, which is what the browser currently uses to make HTTP requests. And I guess we can look at some browser stuff. So I haven't done that much work on the browser this month, but there has been a little bit of things, and I thought I had some demos here, but I guess maybe I don't. I thought I added those. Anyway, I've been adding a bunch of selectors, and we did this style inspector here so that we can look at the CSS of the currently selected element here in the DOM inspector. So that's kind of nice. We can see what the margin values are and so on, what's the font family. And this is just based on the CSS that we resolved for this element. And let me look at my cheat sheet. Okay, so let's look at some file manager stuff. So in file manager now we have, looky here, rubber banding. I'm very, very happy about this because it's something that was bothering me. And it doesn't actually work in all of the different views, but this, at least it takes me to this view now, which is the columns view. This is new, implemented by Sergey. Very, very cool. And I find it very strange, but I like that we have it now. And of course supports keyboard navigation, multi-select, and all of those things. We can now see where symlinks go. It actually shows up down here in the status bar. It's a little thing that I fixed because it was bothering me. Okay, so let me show you some other stuff. We can see now that we have a lot of fonts. These don't come with the system by default. They're actually from a separate project by Tibor, which he has on his GitHub, called Serenity-FontDev. And it's a project to convert all these awesome bitmap fonts to the Serenity font format so that we can access them here and get hello friends. And we can just have all these fun fonts to use, which I'm very, very happy about. And what did I want to show more? I guess I wanted to show some. Oh yeah, right. So we have these radio button looks in the menu now. If something is like a mutually exclusive option, so only one of these can be selected, then they're grouped together and they show up as radio buttons. Just a little thing, but I like it. Oh, and I forgot to mention the font thing, that it actually, oops, it's actually possible to scroll a menu now if it gets too big. So you just scroll it with the scroll wheel. And we have, or at least I thought we had, yes, we do have keyboard navigation in the menu. Another nice thing, although it still needs some work, but it's cool to have. And it is possible to drag a window to the edge like this if you want to make it big and tiny. The other edge works as well. You can drag it up there to maximize. Down doesn't do anything, but this is very, very cool. I think that was Casper who worked on that, so thank you for that awesome feature. And I think it was Yami who did reverse order window switching. Previously, you could only press Win key and Tab to switch forward in the window list. Now you can go backwards with Win Shift Tab, which is, it's this little things, but it's just really awesome how they make the system feel so much better when it just behaves intuitively. Like if I want to go backwards, I just intuitively hold down Shift and try to go backwards, and now that actually works. I love it. So thank you for doing that. And another thing is, if I try to exit here, it will give me this dialog. And these dialogues, you can now actually press Escape to press Cancel, basically. Previously, if you pressed Escape, it wouldn't do anything, but now Escape and Cancel are equivalent, and that's a little improvement from Conrad, which just gives that little enhancement, again, which is super awesome, and I just love that too. Thank you, Conrad. And then up here, you didn't even notice, you can click on this thing now, and it opens up System Monitor. It's just this tiny little patch by Oliver, but I feel like it just makes the desktop feel better, that it sort of does this thing that you expect. You click there and you just expect to get a system monitor, and now you do. So thank you, Oliver, for that one. And yeah, so that's like just a collection of random little GUI things that I like this month. I also spent some time working on terminal emulation, and I did a video where I implemented a whole bunch of missing features that were found by the VT test suite that Brandon ported last month. So thanks again, Brandon, for porting that, because now it's actually kind of easy to work on improving terminal emulation. And then we have a whole bunch of things like work in progress that's it's not finished yet, so I can't really demo it too much, but Andrew has been working a lot on dynamic loading and shared libraries, but it's not quite ready yet, but it's looking really, really cool. And Liav has been working on ACP stuff and a lot of interesting features like IRQ sharing and things like that coming up in the kernel space. And yeah, that's looking really awesome. And then something a little bit unusual that suddenly this month, Brian Callahan showed up and started doing ports, and he ported, I think, 9 pieces of software to the system. And they're just like these awesome little utilities that are super useful in a Unix system, like awk, flex, yak, sed, bc, grep, stuff like that. And we now have them as ports, so that's really, really cool. So thank you, Brian, for doing all of those ports. Okay, so I think that's really everything I had to talk about today. So as you could see, it was a bit less visual than usual because I just spent so much time working on kernel correctness and security, safety things this month. A little bit less GUI than usual, but it's been a really good month, and I feel like the system is in a much, much better place, sort of security architecture-wise now. and we have some seriously good things that we can keep building on. So yeah, I guess I will say thank you so much for tuning in and for keeping up to date with the project. If you ever want to chat, then you can find me every day in the SerenityOS channel on the Freenode IRC network. And it's full of other people who also like talking about the system, and you can usually always find someone in there if you have questions. So yeah, thanks again for watching, and I will see you all next time. Bye.